Another kind of equation is the piecewise equation. And really it just means is we're taking different functions and we're putting them just for a certain time. So for example, for this particular one, when you look at it, x plus 1 is when x is less than 0. So when x is negative, we're going to be dealing with this. So here, x is negative down all the way to there. You know, forever and ever and ever. Okay, notice the open circle here. That open circle is because there's no equal to. If it was equal to, it would be colored in like this one. So x squared is the function for this one when x is positive and 0. So it's filled in here and goes up. So that's really all it means. For certain values, we're going to do a certain equation. So we can have like crazy looking functions with all different kinds of equations as characteristics. So to evaluate them, you have to take into account if like for this example, 2, where does 2 belong? Is 2 less than 0 or is 2 greater than or equal to 0? Well, it's greater than or equal to 0. So 2 will be plugged into this spot. That's it. So if 2 is here, I can look at it this way. This is 2. This is my x value. So what's the y value? What's f of x? Or f of 2? Well, it's 4. Okay? Negative 5. Well, if I look at negative 5, well, negative 5 is all the way over here. What's the y value? Negative 4. So you can see when I did negative 5, I used this equation because that's the equation that I should use because it's for values less than 0. F of 0. So if I want to evaluate f of 0, it's either going to be this one or this one. Well, this is the colored in circle, so it's this one. Okay, so f of 0 is 0. So let's say I wanted to figure out what f of positive 5 is. Well, technically positive 5 is on the graph here, but I just don't see it. It's up here somewhere. What equation did it go with? Well, 5 is positive, so it would be in this one. So I would evaluate it with the x squared. So that's x squared, or 25. I wouldn't do x plus 1 because 5 does not work. 5 isn't negative. All right, so that's how piecewise work. Now we can also do domain and range with these things. For this one, the domain and range are pretty straightforward. Remember, domain, these are the x values, and it's how wide the graph gets. So how far does it go this way? Well, it goes forever. How far does it go this way? It goes forever. Even though we have this spot where, right here, where we kind of have a break where there's really no stop in the x value. If this was an open circle, well, then there would be a break there. So there is no stop there. The range is our y values, how low to how high it goes. So the lowest possible value, how far down does it go? Well, it goes forever. Even though there is a break, there is a jump here in the y values from here to here, these values are actually taken up. If I look for y as a half, there is an x value for that. There's 2, but there's an x value. Okay? So we will be doing domain and range with these also. So here, we might also have to graph them. So this has 3 parts. There could be 20. Okay? But piecewise, you just have to look at the condition here and decide where does it belong. So I don't have the graph yet. We will be having to graph it in a second. So what do? If I want to figure out what f of negative 5 is, well, I figure out where first I look at the condition. Where does negative 5 belong with the x's? Well, it belongs here. So I plug negative 5 into that part. So would that'd be negative 9. Okay. 0. Where does 0 belong? Well, 0 belongs here between negative 2 and positive 3. 0 somewhere in between those. So the absolute value of 0, well, that's 0. And then 8. When x is 8, or here, how convenient, I looked at all three. When x is 8, it's going to be -3. No matter what you get, it's going to be -3. So when I have to graph this, I'm going to start with this one, because that's the easiest in my opinion. So if I want to graph x is greater than 3, so what is the value at x is greater than 3? So what we want to do is kind of create a table of values. So when we create that table of values, I'm going to do it for x is greater than 3. I'm just going to circle this because I kind of messed it up there. So this is our x and this is our y. So x is greater than 3. Well, we're going to start with 3. We're going to start with that border. For x is 3, f of x is -3. That's what it is for everything. When if I put a 4 in, it's -3. If I put a 5 in, it's -3, 6, etc. So if I were to graph that, this one that I start with, we have to be careful because this is just greater than. So that point 3, -3, I have to put an open circle on. Okay, because this is not equal to. It just gets really close. Okay, and then there we go. So the next one that I'm going to do, I'm just going to change colors here so you can see it, is between -2 and 3. Well, between -2 and 3, it's the absolute value of x. Okay, so if I plug a -2 in to the absolute value of x, it's the absolute value of -2, which is +2. And then say do -1. So I want to do it in this full range. So I go from to 3. Let me just move down a little. So -1 would be +1. 0 would be 0. 1 is 1. 2 is 2. And 3 is 3. So you can do this in your calculator and you can look at the table of values. It doesn't matter. The equations are going to get slightly more complicated, so you're going to want to do that sometimes. But in this case, it's pretty straightforward. So first I have to look at my endpoints. These are my two endpoints. Are they equal to or not? Yes, they're equal to, so that means I'm going to have a colored in circle when I do these two pieces. So -2, +2, -1. I'm just plotting all those points. Obviously, it's just the endpoints that really need to be done. But no arrows, just make sure there's solid circle here and here. Okay, and then the last one is 2x plus 1 for x is less than or equal to -2. Is that x? I can't see it, sorry. Yeah, less than or equal to -2. We're going to do 2x plus 1. So here's my x and my y. So if I plug in, I'm going to plug in -2, -3, -4, -5. Always want to stay within that condition. Obviously my numbers aren't going up in the same way. Here they're going up, here they're going down. But whatever, there's still points to be plotted. So plug in a -2, I get a -3. Plug in a -3, I get a -5. Plug in a -4, a -7, and plug in a -5. Remember, I'm doing this. So that's -10 plus 1, that's -9. So these are 3 points that I can look at, or you can plot the graph however you want. Okay, so plotting this, it would be -2, -3, which is here. And remember, this is an equal to. Right here we have an equal to, so it's going to be a colored in circle. -2, -3, -3, -5. -4, -7, and I can't fit the last one on there, so I'll just do this. There is an arrow on that one because it does go on forever. It's not a range of values. Okay, so this is what this piecewise looks like. This is not a function. Okay, so this, is it a function? What we want to do is look at what makes something a function. Something is a function if it passes the vertical line test. Sorry. Passes the vertical line test. Or, another way of saying it, the x's don't repeat. So what that means is this point right here is the point -2, 2. And this point right here is the point -2, -3. See the x's? They repeat. It's the same as if I were to draw a vertical line from here down. It'll hit twice. And if it hits twice, it's not a function. Okay. This one up here, if you look here, is this one a function? If I draw the vertical line right here, it doesn't actually hit there because that's an open circle. It really only hits once, so this one is a function. Okay, so just have to remember that for future, what is a function. Have a wonderful day. Adieu.